Hi. So today we'll start this webinar on the topic of OpenStack automation. So before starting this, I would like to just do introduction about me. So good morning, everyone. So my name is Sohail Akhtar. I'm working at Prodevance as a senior technical consultant. So I am having a 5 years of experience in IT. I'm certified in cloud forms, Ansible, RSC, and MCSE. So today, this topic of this webinar is OpenStack automation, sponsored by Crayon. So we, Prodevance Technology, are leading Red Hat business technical and training partners for Red Hat. Today, I'm showcasing how we can do OpenStack automation. So I believe that those who are attending this webinar does have this knowledge on the cloud and orchestration engine. So let's start this webinar. So before starting that, I'd like to discuss what is cloud. Cloud is actually a service based on the service based on the requirement that the user is using the services. What based on their requirements, user can use the services. So this cloud is basically of two types. One is a private and the public. And the private cloud is actually what that's a cloud which is set up on premise, and the public cloud we know that the public cloud which is like AWS, GCP, Alibaba, Azure, etc. So nowadays most of the companies are using the hybrid cloud. They have a both uh, cloud on premise and a public cloud both. So before starting, we'll start with the agenda. That's the agenda. What we'll cover? We'll cover introduction to the OpenStack, its feature, and triple O, and architecture of the triple O, uh, heat template and heat templates components, its architecture, and the sample of the heat template. And we'll discuss about the Ansible, its architecture, and what modules you can use to automate the what modules you can use for Ansible to automate OpenStack. So we'll start with the OpenStack. So OpenStack is the cloud operating system that's it has a control of large pool of compute, storage, and networking resources uh, through a data center, all managed through a dashboard. It's a open source software, and we can use most of our services like it has a basic services like Nova, Sender, Glance. So these are the services we can use in the OpenStack. So basically, so you can see that in compute, the OpenStack is using the services compute. The compute is nothing but a using a Nova services, and storage, for storage we can use Sender and Swift. And networking is a basic requirement. That's nothing but a Neutron. So here, uh, what what the features we have, what are the features of this OpenStack is. So in OpenStack, you can see this these are features: the leverage commodity hardware. So in this, you can lock in, and having a low price at per GB, we can use. And we can see this next feature is hard disk node failure agnostic. So it is having a self-healing, reliable, and data redundancy product from failure, because all these things are available virtually. Unlimited storage. So unlimited storage is like large and flat namespace we can use. Highly scalable read write access, able to serve uh, Yeah, able to serve uh, able to serve content directly from a storage system, and multi-dimensional scalability that has a scale out architecture, scaling vertically and horizontally, distributed storage, backup and archive large amount of data with linear performance. And this account and container object is another feature. Is account and container object storage. So in this, it is actually there's a no nesting, not a traditional file system, optimized for a scale. It is a scale to multiple petabytes of billions of objects. And one more thing, there's another feature is the built-in replication 3x plus data redundancy compared with 2x on RAID. So we can implement RAID over here. So for RAID, what you require is a configurable number of accounts, containers, and object of high availability it requires. Easily and capacity, unlike RAID size. For example, we can use elastic data scaling with ease, and no central database and high. Um, Another thing is that it doesn't have it doesn't have no central database, like high performance, no bottleneck, and the RAID not required over here. So RAID here is handle many small random reads and write efficiency. Built-in management utilities are here, so you can manage your account management, create and verify, delete users container, manage upload, download, and very uh, monitoring capacity is also monitoring capacity, host networks, and cluster health. You can check the cluster health also. And it has this driving audit is actually like it detects the drive failures, preemptive data corruptions. These are the things we can manage over here. So another is this expiring objects. User cannot set an expiration time on the TTL uh, on an object to control access. So this task is handled by the admin. uh, Direct object access enables direct browser access to the content, such as for a control panel. So, and one more thing that is has there's support three S3 API. So utilize tools were designed for the popular S3 API. Means we can connect we can use the storage which is from AWS. Okay, uh, so these are the features of OpenStack. And next is that's the best. What is the triple O? So triple O is nothing but a project that's through which we can manage our infrastructure, that is nothing but a under cloud and over cloud. So here, what is actually a under cloud? Under cloud is actually it is a director machine where uh, it is it provides the infrastructure for your over cloud nodes. Okay, so in that, what we can do here, you can see this diagram. It is showing this Red Hat OpenStack platform under cloud deploys and manage over clouds. So Triple O is actually is a set of tools for deploying and managing OpenStack. Its name is Triple O, refers to it is OpenStack on OpenStack, means on top of the OpenStack, which is the infrastructure. On top of that, we are deploying another OpenStack to manage. That is nothing but a over cloud. So it is designed here. It is written as a design pattern where the underlying OpenStack instance is used to deploy and then manage other using usually more complex OpenStack instances. So a set of configuration files, a script which contains OS image, build rules, and service configuration rules. So these are the things we can manage in triple O. So you can see this, the what are the services and what you can what are the services you are running on under cloud, and what services you're running we are running on over cloud. So in this you can see this OpenStack deployment, that is nothing but a director, and under cloud is also using an OpenStack entity, nothing but a keystone. The dashboard, it is having a horizon and orchestration, that is it is using a heat template, and there's a compute, that's nothing but a Nova, and images, that is nothing but a glance, and the bare metal, that is nothing but a ironic service, and this new networking, that is nothing but a neutron. Okay, and the other services, the last services is OpenStack telemetry, that is nothing but a ceilometer. Okay, so this is what on using this under cloud infrastructure we are deploying this deploy, update, and monitor. So it is on over cloud, it is deploying these services. These are the, you can see this this yellow sign, and this blue is storage. So these whatever the services we are seeing here, these are the basic services required for the over cloud. Okay, so the same, the services which we are deploying over here, the same services which is running in a over cloud, but it is running on top of the under cloud. So next we are going to after discussion we are going to the architecture. So you can see this, the flow of under cloud and over cloud. This is actually a flow of the OpenStack. How your how the user can provision their VM, how the communication is done with all the services. So basically, the communication is done with the help of the API. There's an API like here. There's a user is able to access the horizon. That's nothing but a dashboard on if the user wants to access or user wants to deploy any services, like if he wants to access any bare metal service. So for bare metal service, the user has to connect with this ironic API, then it is able to use the service. So here you can see this, every services user the horizon is connected with each and every API first. So your horizon is connected with ironic API, as horizon is connected with the heat API, then it is connected with the Nova API, that is connected to the Trove API. Trove is nothing but a database service, and it is connected with the Swift proxy server. So everything is the communication is done with the help of the API. Okay, so today that's what we are base means today we are discussing the main thing we are discussing, that's the heat template, because this topic is based on the automation. So here, as you can see, there's a heat orchestration that is used for automation. Okay, and here there's a keystone, that's a keystone services here for the identity, and ceilometer, this is complete architecture how it is communicating. You can see the flow, that's how we can connect and how it is which each and every services is running. So coming to the main topic, that's a heat orchestration template. Okay, so what is this heat template? So in terms of OpenStack, it is actually called a hot. Hot stands for heat orchestration template. Okay, so this is one of the project, if we talk about the OpenStack community project. So heat is, you can say that's in OpenStack, each and every services what we are using, like Nova, uh, Sender, Swift, and Neutron, each and every services is taken as a project. So heat is also like a project which is used for orchestration in OpenStack. Okay, so here you can see that Heat is a main project in an OpenStack orchestration program. It implements an orchestration engine to launch multiple composite cloud application based on templates in the form of text file that can treat like code. So what is this heat template and how it looks like and why we are using? So before going ahead, I'd like to inform you, if anybody has any questions or any queries, please drop your queries on chat board. Chat will see that's your query, and will try to answer uh, once we'll finish our presentation. So going ahead, that's we'll go to the first. We'll see this is the definition, and this is, you can see this heat also endeavor to provide compatibility with the AWS cloud formation template. If you see the structure of this cloud uh, heat template, you will able to you can see this the same structure, what the same structure of the cloud formation template that's used by the AWS. The same structure we are using for heat template. That's the same syntax it is using. Okay, so next we are going to we'll discuss this heat template components. So these are the heat components. So here you can see this the components. There are four components: the heat API, and heat API CFN, and API. Uh, sorry, actually there's a mistake. So it is actually a heat engine. Okay, so this is actually a heat engine. So heat is actually what? Heat is it is the uh, CLI that communicates with heat API. Okay, and heat API is a component that provides an OpenStack native REST API that process the request and sends them to the heat engine. So heat API CFN is this heat API CFN, that is, it is a component that provides an AWS style query API that is compatible with AWS cloud formation and process the request and send them to the heat engine. Okay, so heat engine is what? Heat engine is just like a brain of the operation and does the main work of the orchestrating the launch of templates and provide the events back to the API consumer. Okay, so just take a look to this architecture. You are able to see that's how this heat template is executing and how it is communicating to each and other, how the services are communicating with each other. So here you can see this, the user is as user is able to access the dashboard service that is nothing but a horizon. Okay, so user can communicate to uh, 1 minute. So user can communicate to the heat API because in OpenStack, the services, the communication to the services is done with the help of API tokens. So here, this user will log into the dashboard, and this communication that it is this the user is authentication is done with the help of identity service that is nothing but a keystone. Okay, that is nothing but a keystone. So this will communicate, and this keystone will generate an token, a token. That token is sent to this OpenStack Heat API, and this Heat API will communicate, will send the code to OpenStack Heat Engine. Okay, so this is how it is executing. Okay, so a heat template describes the infrastructure for a what this template contains. So heat template contains the infrastructure for a cloud application in a text file that is readable and writable by the human, and can be checked into version control and dived, etc. So infrastructure resources that can be described, including like what these services, what resources we can provide, like the resources which is we can provide the server information, floating IPs, volumes, security groups, users, etc. So heat will also, what heat can do, heat can also provide an auto scaling service that integrates with telemetry. So you can include a scaling group as a resource in a template. Like if you have a VM, and generally we are like you can say that, for example, uh, uh, that's a Flipkart cell. Okay, so Flipkart cell is having words. So sometimes it is having a sales of so it is, we know that the Flipkart is using, that's like it is using the services from AWS. So what it is doing, it is, it is like whenever the load is increasing, it is doing a auto scale. Okay, so the services which is running on the on running on the AWS, it is auto scaling. So in the same way, so it is done with the help of your AWS cloud formation template. In a similar fashion, we are doing the same thing in OpenStack using heat orchestration template. So whenever that's load will increase, that's we can schedule our uh, heat template, and then it will do a auto scaling. It will increase the load, and the and once that load is not required, it will decrease. So we can do all these things using a heat template. So we are discussing about this, how this communication is doing. So here, that's the main thing of this heat template is heat orchestration is the OpenStack heat engine. This services is responsible to uh, to do the deployment. So this services is exist on a controller node, and this heat orchestration heat engine is associated with a orchestration database. Okay, so whenever we'll deploy, this will deploy, and it will create this virtual machines. Like here it's a compute services, and it is, you are able to see that's created infrastructure. So like this, it will deploy this VMs, that's instances. So okay, so what, how this heat templates looks like, what is the skeleton? So you can see this, what this heat template contains. Heat templates contains version, description, parameter groups, parameters, resources, output, and conditions. Okay, so uh, what this description, what the version, the version is like, you can see this here, that's 14.10.16. So 14.10.16 means it is defined some parameters which is already it will deploy. Description here, uh, before descriptions, that's the key of value is like we can set the date like 23/5/2013. All these dates are defined. That is used as a version that indicates that YAML document is a hot template of the specified version. And the next thing, that's description. What this description contains? This optional key allows, this is optional, if you want to use you can use. So this optional key allows for giving a description of the template or the workload that can be deployed using the template. Next, the next parameter is parameter underscore groups. This section allows for specifying how the input parameters should be grouped and the order to provide the parameter in. This section is optional and can be omitted when necessary. The another is that's parameter. So this section allows for the specifying input parameters that have to be provided when instantiating the template. The section is optional and can be omitted when no input is required. If user has any input, if user wants to provide any input, at that time it is necessary. Otherwise, if we are not providing any input, if you are not providing any input from the user, it is not required. The next is that it is resources. The next option is resources. So the resources, this section contains the declaration of the single resource of the template. This section with the least one resource should be defined in any hot template, or template would not really do anything when being instantiated. So whatever resources, like resources, you can define this what services you requires. Okay, so number, VM name, instance name, and how many CPUs required, what disk size is required, how many NICs are required. Okay, so these resources we have to provide over here. Okay, so another is that's output section. In the output section, what it contains, the output is nothing but just whatever, just like we are deploying any hit template. So it is provide me some defined output. So yeah, this VM, yeah, if we are instantiating any VM, we are creating any VM, yeah, any instances. So it will just give me the information. Yeah, your VM is your instance is created, and this is the user ID and password you can use to log into your instance. Okay, so here the section defines like this section allows for specifying output parameters available to users once template has been instantiated. This section is optional and can be omitted when it is required. If you don't want to show any output, you can omit this. Another is like condition. So another is a condition, like here we can say this option includes a statement which can be used to restrict when a resource is created or when a property is defined. They can be associated with resources and resource properties in the resources section, also can be associated with outputs in the output section of a template. So here we can restrict if we want to restrict a particular user. So they cannot provision any instance. They cannot provision more than 3 instances. So we can restrict those users over here so that whenever they wants to provision a instance, so they cannot provision more than 3 instances or more than 4 instances, whatever condition we are providing. Based on the condition, they cannot provision more than those VMs, more than the instances. Okay, so this is the complete brief information about this syntax, how syntax of heat template. Okay, so uh, how this heat templates looks like. Okay, so you can see here that this is your heat template, and this heat template is looks like this. Okay, so what is in this heat template, what we are doing? So as you know that we have given this version, that's a 23/5/2013. That is nothing but a version. That is actually a date, but in terms of a heat template, it is a version. Description is what? Description is hot template that just defines a single application server, and the parameters which we have provided, that is image, flavor, key name, net id, and security group name. So these are the parameters we have provided. So here, as you can see, that's a image, and its subparameter is type is a string. Description, this image is used for the server. That's the default image is we are using Cirrus. Excuse me. Flavor is the flavor, and it again has a three parameters, that is type, string. Description is the flavor to be used for the server. So that's flavor which is we are using here, m1.tiny. Key name, that is again a type descriptions, and the default key name we have given this a key pair. Okay, so in a similar fashion we are using the net id. So whenever we are provisioning any instances, we are spawning instances. So at the time of spawning an instance, we are using, that's a private network, that's a network, so that's we are defined over here. And security group, we are using the default security group, so its type is a string, and default option is default. And the next is we are having the resources. The resources option is server, type is os, so it is using the service which is Nova. On top of that, we are deploying a server. Property, what property it contains, the name of the server is test hyphen vm, and image get underscore param colon image. So it will collect the image from over here. That's the image is a Cirrus. Okay. So when we'll deploy this hit template, so after deployment, it will come like this. Okay, so here you can see this is the orchestration. So when you will deploy, you will able to see that's how it is provisioning, how each and every services is coming up. Okay, so this is the example how your heat templates, how we can orchestrate, uh, how we can automate the OpenStack services with the help of heat template. Okay, so another way of automation is we can automate OpenStack with the help of Ansible. So next we'll discuss about the Ansible. I hope few people knows about the Ansible, but here we are discussing about the uh, automation. So definitely Ansible comes in the picture. So what is Ansible? So Ansible is an open source uh, orchestration tool. It is simple, it is powerful, and it is agentless. Okay, so what you can do with the Ansible is radically a simple IT automation engine that automates cloud provisioning, configuration management, application deployment, intra-service orchestration, and many other IT needs. Okay, so why this Ansible is simple? Because we have seen this orchestration templates. So in orchestration templates, I'm going to the last slide. Okay, so here in this orchestration templates, you are able to see that say, a normal user can able to understand this what this orchestration or what this uh, heat template is doing. And if I don't understand this heat template, even though I can learn and I can say that it is using what. So here it is using this image, that is Cirrus image, flavor which is m.tiny, that's a flavor, that's a key name. I'm able to see, I'm able to learn. Okay, so in the same fashion, this Ansible is easy, and Ansible is a human readable. So that's why this Ansible is easy, and it is agentless because uh, we don't, if we want to deploy any application to the managed nodes. Okay, so managed nodes in the sense like we have a 5,000 of servers, or in a server there is a one system that's having an Ansible that is actually a control node, and the rest of the server which is managed by the Ansible, that is known as a managed node. So to deploy the services with the help of Ansible, you need Ansible to be installed on a control node, and you don't need any agent software to the managed nodes, so that whenever you want to deploy any services to the managed nodes, you can deploy, because Ansible is using the services which is nothing but a SSH. On OpenSSH, it is executing. And the important part is for Ansible is developed on Python, and to execute any playbook or any to deploy any services to the managed nodes, you have to be sure that both your control node and managed nodes have must have Python. Python to be installed on your both the nodes. Okay, so coming to the next, this architecture of Ansible, how the Ansible communicate with your private cloud, and how it is communicating with the other services. So here you can see this user is nothing but an Ansible user. Okay, so Ansible users write the playbook, and this playbooks is contains the Ansible modules. Using these Ansible modules, we can deploy this required services. So where we are deploying the services, so the services which we are deploying to the inventory, here this inventory is nothing but a it contains the information about your managed nodes. It could be public cloud, it could be private cloud, it could be your infrastructure, anything. So it is like a host. The inventory contains the information about your host. Or what you can do, you can manage the network services also. So here we can manage public cloud, private cloud, host, and networks. So plugins are required. So plugins like if you want to use the other services, so in that case we require this plugins. Okay, and the CMDB, that is nothing but a configuration management database. This contains your complete information. This whatever inventory you are updated, this inventory information is updated to this configuration management database. Okay, so this is how your Ansible automation engine works, and you can manage your uh, private cloud or public cloud or any managed nodes. Okay, so now coming to um, excuse me. Okay, so uh, here that's how we can use what are the modules available in OpenStack that we can use for automation. So you can see here there's OS authentication and OS client configuration. These are the modules which is available to the OpenStack to manage or to deploy any services with the help of Ansible. So to deploy any services to OpenStack, like if you want to provision your spawn any VM, or if you want to spawn any services, okay, so you require one more package that is called OpenStack SDK. Okay, that you have to install on your control node, that is in Ansible. If you don't have that package, your Ansible modules cannot communicate to your OpenStack infrastructure. So here is like you can see this. If you want to deploy any pack, if you want to create a group, we can create os underscore group is used to create a group. Images, if you have any images we want to add or delete any images, we can add it with the help of os underscore image. Or we can manage like bare metal services, bare metal resources. So we know that's ironic services is used. So this module will communicate with the ironic service. So in same, you can see this key pair and keystone endpoints. That's identity services. So this module, whatever is comes with the keystone, like OS keystone domain, OS keystone domain facts, keystone endpoint, OS keystone role, keystone services. So these modules communicate with our keystone services and the load balancer, network facts. So these will communicate with the Neutron, Nova Flavor, Nova Host Aggregate. These will communicate with the Nova service. That's for compute. Okay, for network, here we have OS port, OS router. So these things we can manage with the we can use for Ansible uh, to deploy any services. Okay, so here to create any service, create any server. If you want to create any VM on any instance to the OpenStack, you can use OS underscore server module to deploy an instance. Okay, so these are the modules available here. With the help of these modules, we can write the playbooks, we can deploy the services. Okay, so so uh, this is what we have that's in today's agenda. So if anyone has any queries, any questions, please let us know. Yeah, we have uh, some questions. Okay, we do not have any questions. So please ask if you have any questions, any queries, please let us know so that we can answer. Uh, One of the friend asked for how can replace VMware to OpenStack. So this I'm very much in trouble to pronounce your name, but even though. So for VMware, this is VMware. What you are talking about means you are talking about the vCenter, or you are talking about the vCloud, because definitely we can. Okay, so vCloud. Uh, I think that's we can do, because I do not have much exposure on vCloud, but I'll try to answer it. Uh, you can replace it, because most of the services are available. We can replace this VMware vCloud with OpenStack. Okay, because uh, we can use all the services which are available. And one more thing, that's for vCloud, uh, you need a subscription. You require subscription. Without a subscription, we cannot use. What will the benefit, because vCloud is licensed tools? So definitely vCloud is having a license, so you will take a lot of licensing and pricing. Yeah, thanks Maran, that's very much helpful, because this is the important thing regarding the OpenStack, because OpenStack is open source, And definitely in a open source, we can do lots of things. We can customize it to thing for multiple servers. Yeah. Uh, so one of the asked how to automate patching using Ansible for multiple servers. Yes. So your Ansible is okay. So your Ansible is like we have talked. Let me go through this architecture so that you will have a better understanding. Okay, so in this you can see that's a user. Okay, so user, in this you have an inventory. So whatever instances you have in your OpenStack, that has to be in inventory. And using that inventory, you can just write a playbook. With the help of this playbook, you can do a patching. You can run all the patching or that's playbook to all your managed nodes, which is in inventory. Okay, so one of the friends asked in OpenStack Infra, Windows VMs or Linux VMs license are free. Uh, for Windows, that's is not free. Actually, Windows is coming with the 30 days of license. Okay, 30 days of freelance license. After that, you have to purchase it because it's a proprietary of Microsoft. Okay, but Linux is open source. Linux is free. You don't need any license for Linux. Okay, and this Sajit, yeah, we can create a playbook for patching the all ISO servers. Yes, that's a true answer. How it's one of the question that's how can we figure out the pricing things as compared to vCloud and any platform to calculate the price for the OpenStack and vCloud. So that's is a very good, very much difficult for me because I belongs to the technical team. Okay, so that's you can talk to this that team which is dealing with the business. Okay, so that's they are the right person to answer you about these questions. Okay, so another is that is possible to run or try OpenStack on my PC. Yes, you can try, but it requires the higher configuration. If your laptop is if your laptop or if your system is having that the configuration, that definitely you can deploy OpenStack on your PC. But as a user we have a less number, we cannot afford a high configuration system, so it is very difficult to deploy other services of OpenStack, so that might could be a problem. Okay, so hi Bhargav, so please check me this. Yes, so any other query or like any questions? We are having a we are still having a time, so we can. What about AWX for Ansible? Yeah, so AWX is a open source and it is having a GUI mode also. This is AWX is a open source for Ansible. That is nothing but your Ansible tower. Okay, so if you want to use a open source Ansible tower, you can use a AWX. So any other? Can we get the recording of this session? That you talk to the Maran, and if it is possible, then we can.
Yeah, it was recording. It was recording. Yes.
Yeah, so with Ansible Tower, you'll get lots of facilities because definitely one of the facility that will you'll get a support. Okay, so based on the license, based on the license, that's how much of nodes you want. Based on that license, you will get this those features. Uh, Sajid will definitely let you know. That's another will mail you. Will let you know this, what we will do with another webinar on Ansible. Definitely, we are trying to make good, and definitely we'll come up with another topic with Ansible. Okay, so we'll definitely let you know. Yeah, so this is we are on triple O method. We are discussing. Yes. Can I see it almost like done with an OpenStack? I don't think this. I can say this AWS is can be done within OpenStack. This is it's quite confusing because why you want to deploy this, why you want this OpenStack on AWS? That's nothing of use. But yeah, it depends on the requirement. If customer needs, we can do this. It depends on the customer requirement. So Jalal, this is based on the requirement of the customer. So if anyone has any questions, so we'll try to we'll winding it up. So if anyone has any query, please ask. Or
Thanks, Sohel, for your very informative session.
yeah, Varan, thank you.
Thank you. Bye.
Yeah, yeah. So if anyone has any query, so we'll still there. Okay, thank you, Sajid. Yeah, okay.
Any doubts, call me. You type that message.
Okay, friends. So definitely we'll meet with another session with new topics, with some new ideas. Okay. Jalal, thanks, but I'm not a professor. Okay. So thank you. Thanks, everyone. Thanks to Joanne. Thanks for your time. Thank you.